In this problem, we need to resolve the given rational fraction into partial fraction. So let's begin. First, all we need to check is that the degree of the numerator must be always less than the degree of the denominator. Clearly, if we look at the numerator, then the highest power of x in the numerator is 1 and the highest power of x in the denominator is 2. So that means the degree of the numerator part is 1 and the degree of the denominator is 2. Since the numerator's degree is less than the degree of the denominator, so we can proceed. Now, the next task would be to factorize x squared minus x minus 2. So using standard algebraic techniques, the factorization will be x minus 2 times x plus 1. So that means we can rewrite 2x minus 1, our given rational fraction, divided by x squared minus x minus 2 as equals to 2x minus 1 divided by x minus 2 multiplied to x plus 1. Now the whole reason we're doing this so that we can let 2x minus 1 divided by x minus 2 multiplied to x plus 1. So this can be also expressed as the sum of two partial fractions, which is a over x minus 2 plus b over x plus 1. So our task will be in this problem to obtain the value of a and b. So let's begin. To find out the value of a and b, all we have to do is we'll have to multiply both sides of the equation with the denominator x minus 2 times x plus 1. That means on the left hand side we simply have 2x minus 1. On the right hand side we have x minus 2 times x plus 1 multiplied to a over x minus 2. So that's going to be x plus 1 whole multiplied to a. Then for the second term we have b over x plus 1. So that's multiplied to x minus 2 times x plus 1. Clearly x plus 1 will get factored out. So we'll be left with x minus 2 times b. So let's solve this equation. So we have 2x minus 1 equals to x times a plus x times b minus 2b. So 2x minus 1 will be equals to, we'll combine the terms containing x. So we have x multiplied to a plus b. And then we're going to combine the constant terms, which is a minus 2b. Now, what we are going to do, we're going to compare both sides of the equation because we have an algebraic expression on the left hand side as well as on the right hand side. Now, comparing both sides, we can see that the coefficient of x are going to be equal. So that means coefficient of x on the right hand side is a plus b, and that will be equal to coefficient of x on the left hand side, which is 2. And then we're going to compare the constant term. So a minus 2b is the constant term for the right hand side. So that will be equals to the constant term on the left hand side, which is negative 1. So we have two equations, two linear equations, and a and b. We can solve them to obtain the value of a and b. So let's do that. So all we have to do is we are going to take the first one, a plus b, and from it we're going to subtract the second one, which is a minus 2b. So this will be equals to 2 minus negative 1. So we get a plus b minus a plus 2b, which will be equals to 3. So a and negative a cancels out. The b times 2b, that will be 3b. So 3b will be equals to 3. Solving for b, we get b equals to 1. Then we can substitute the value of b with 1 in a plus b equals to 2. And that's going to give us a value a equals to 1. So here we have obtained the value of a and b, which can be now replaced into this equation. And then we can finally say that our given partial fraction, which is 2x minus 1 divided by x squared minus x minus 2, so that can be resolved into two partial fractions as a over x minus 2, or a value is 1 over x minus 2, plus b value is also 1, so we have 1 over x plus 1. So this is the required result.